There's a couple other people that are coming but running a little bit late. For those of you who don't know me, I'm Dean Grant, Director of the Center here at the Center. So welcome to the final presentations of the 2016 Summer Seed Grant. First of all, I'd like to thank our sponsors, Wild Catalyst Network, which is a group of alumni, parents, and friends of UNH, who have generously funded this and several other programs to help sort of grow the idea, innovation, and entrepreneurship culture at UNH. Kennebuck Savings is a sponsor. They have an office across the street. We did a small interaction with the groups this summer. Raka Interactive, which is actually owned by a UNH alum. He provided some marketing expertise, did the logos for both teams, and we thank them. And then most of all, the mentors. So from Alpha Law, Mark Kaplan and Josh Steer, who work with the students every week and really help to move them along. So without them, not where we were today. A little bit about sort of the Summer Seed Grant, and then we'll have two presentations, and then Mark and Josh will finish it up at the end and talk about their experiences and their interactions with it. So this is the second year of Summer Seed Grant. We learned a lot in the first year, put a little bit more rigor around it. Basically, it was $3,500 per student to be able to work on their startup idea over the course of the summer and not have to get a summer job. So it's really sort of a way to help accelerate with time and money those ideas that nurture. We had 12 students that presented. A judging team of 5 selected the 2 pilot teams who are great teams for this. And so they'll talk about where they started, what they did, where they ended up, and we'll go from there. So with no further ado, we'll start with Project OASIS, and then we'll do Radex, do a break in between, and then Josh and Mark at the end will sort of wrap it up for us.
Thank you, Ian. All right. Good morning, everyone. We are OASIS, optimizing aquaponic systems to improve sustainability. And I'm Sid Nagam, co-founder, and I'm off to Colorado in 3 hours for grad school.
And I'm Paige Beckham. I'm also a co-founder of OASIS with Sid. We both just graduated from mechanical engineering back in May. I'm heading to Uganda in September. I got a Fulbright grant to research aquaponics in Uganda for 9 months. And then I'll be heading to grad school at UC Berkeley when I get back.
And I'm Ethan Peary. I'm going to be leading the team next year because I'm going to be staying way closer to home here at UNH, senior mechanical engineer.
So let's start with a story. We're going to go from our past to our present and to the future. We're going to talk to you guys a little bit about our project overview. So when we started as a project designing, building, and implementing aquaponic systems which would be affordable and energy efficient in developing nations. We placed first at the undergraduate research conference last year, third at Social Venture Innovation Challenge, and we were Holloway semifinalists in the sustainability track. Let's take a quick look at our Holloway video to understand what aquaponics really is.
Currently, aquaponics systems that are available today are either too costly to purchase and operate, or they're do-it-yourself systems. Ours is the first to be analyzed from an engineering perspective at this scale.
The idea behind aquaponics is to combine aquaculture, the growing of fish, with hydroponics, the growing of plants without soil. The fish waste provides the nutrients for the plants, while the plants support the fish. One study has shown that aquaponics is 10 times more productive than conventional farming methods.
Using advanced engineering tools is an innovative way of significantly decreasing the operational costs of aquaponic systems. These systems are more affordable in both developed and developing countries.
The computational fluid dynamics research that we're doing at this scale has never been done before. We're basically using OpenFOAM to understand the flow within our system and to optimize our design.
We're in the process of constructing the systems now. On this side, we'll have the traditional system, which we'll be able to compare to our research system on the opposite side of the greenhouse.
Currently, we're designing our minimal viable product. The capital from Hall. So that's the most important part about aquaponics. It's a symbiotic relationship between plants and fish.
And so we were also able to partner with a nonprofit organization in Uvita, Costa Rica. Porjando Las is an after-school program where disadvantaged kids can come and learn life skills as well as just have a safe place to hang out after school. So this past January, 4 of our team was able to go down and actually be able to visit Uvita and really be able to meet the people, understand the community, what their needs were. We were able to scope out the site, figure out what kind of materials and resources they have available, and just make that connection and build that relationship with the community. We found out that Uvita is a perfect place for aquaponics because it's really hot and humid, so it's great for growing plants. But they also have a problem with their soil. Their soil is such poor quality, they can't grow vegetables themselves. So aquaponics would enable them to do that. So we came back to UNH and designed a system that could work in Costa Rica. We built it at the UNH McFarlane greenhouses. In the video you saw the construction. This is the completed side-by-side research system and traditional system, so we could compare them. So our design used 3 plant beds and then 2 fish tanks. The fish tanks are unique because they're rectangular. We used IBC totes, which are universally available around the world, including developing countries, and they're also much less expensive than the traditional circular fish tanks. The problem though is the rectangular design makes the flow very difficult to remove the waste from the fish, which is an important part of aquaponics. So we did the computational modeling to model the flow, and as Ethan will talk about, we do more of that this summer.
So yeah, hopefully this wrapped up an entire year of engineering and just project work in general. So now we get to why we're here, summer seed grant and what we did over the summer and what we wanted to accomplish. First, we wanted to find a viable business model which would allow for the funding of the implementation trips, which Paige talked about the assessment. We wanted to fund those in the future. In order to do that, we needed to recruit new team members because at the time it was mainly engineers and not much external expertise. So we needed business students, sustainable agriculture students, biology students, you name it. We needed it, and we were going to find it this summer. After that, we were going to train the next generation, which is me leading it, and the rest of the students that we were going to find this summer. And finally, we are engineers, so we still needed to do some science. We really needed to tackle the fish tank flow problem, and that was already described, and we wanted to tackle that. So to do the business model, we had to really learn everything about it because we had no idea what was going on. So Mark Kaplan and Joshua Sear over at AlphaLoft led us to Udacity, which is an free online business course that really teaches you the ropes, starts from the startup of a company. And
So after a week of intensive online crash course, we were clearly experts at the business model canvas, right? Not quite. As you can see from our first attempt at our business model canvas, we had lots of question marks all over the place, a few probablys here and there, and really we were trying to understand, but I think that was still a huge gap. For instance, our first customer segments was high schools with agricultural programs, and then later pivot to urban rooftops. But we quickly realized how terrible of an idea that was. So what do? We decided we'll go outside and learn. We'll learn from the people, see what kind of systems they want for their homes, whether our large-scale systems would be good to enter the US market. And so we went to talk to people and customers at Hannaford's, at farmers markets, you name it, all the grocery stores and organic food stores. And we also questioned and talked to the fish at Petco to see what kind of humans they would like to live with. And we gained a lot of valuable market insight.
So we went back and analyzed the data. It was actually pretty surprising. Some of it was really encouraging, like 60% said they'd be interested in having an aquaponics system in their home. What was a little concerning though was that an even larger percentage said they wanted a smaller indoor aquaponics system versus a large outdoor design like our current system. So this sent us back to the drawing board. We realized that if we wanted to appeal to the US market to be able to support our developing nations projects, that we would need to make a totally new aquaponic design. So we continued to question the customers and see what kind of design would they actually want. We were surprised to find that only 40% said they'd be willing to clean and gut the fish themselves. One of the best parts of aquaponics is you have this fish you can harvest, which is great for developing nations where you have that added protein source. But here in America, people don't want to deal with that messiness of harvesting fish. So we decided to go with ornamental fish, that still provide the nutrients necessary for an aquaponics system, but people don't have to deal with the hassle of harvesting them. We also found that people were more interested in a less expensive kind of functional system that they could assemble themselves versus a flashier design that's like already assembled and sent to their door. People wanted to spend less and be hobbyists themselves to be able to get their hands dirty and in their own aquaponics system. We also asked people how much they're willing to spend. It's a hard question. We were surprised that the majority said 1 to 2K. We think this data is slightly skewed because whenever we ask this question, we always preface it with a speech about how expensive aquaponics is, especially the startup capital, and that the biggest competitor in the market charges $4,500. So people definitely didn't want to spend that much, but we think realistically people want to spend less than $1,000. We also asked what the largest barriers were to people when looking at home aquaponics, and by far people said time or convenience was the biggest hindrance. We can't really do much about the 12% that said they don't want to eat veggies enough, but the rest of the problems we can address.
So with all this market research, we had to head right back to the business model campus. We realized that we had some great ideas and some really bad ideas as well. Start off with the bad. High schools, particularly high schools with agriculture programs, were our main demographic customer segment. We realized this was way too narrow and it just wasn't going to work. So we decided to shift directly to the consumer market. Individuals, households, anyone for a small scale system for one sale. And that way we could get more sales. But we did have also another pretty good idea, a manual, which would guide the customer through the entire experience of building a do-it-yourself